right, let's look at page 2 of our study guide. We have x, x, and x for a, b, and c, and we are asked not to find x, but to find a. But in order to find a, we got to find x. So we know if we add our three angles together, 3x minus 4 plus 9x plus 17 plus 6x minus 31 is going to equal 180. Let's combine like terms. 3x and 9x is 12x. 12 plus 6 is 18. Negative 4 and 17 is 13. 13 minus 31 is going to give us a negative 18. And that's going to equal 180. All right, let's solve this equation by adding 18 to both sides, and we'll get 18x is equal to 198. Divide both sides by 18, and x is equal to 11. But that's not what we need. The question asks us to find angle A. Angle A is equal to 9x plus 17, which will be 9 times 11 plus 17. Or 99 plus 17, which is going to give us 116 degrees. Make sure you put your degree symbol. And we've answered the question. On number 8, we again have an exterior angle right here, 10x minus 23. So it's equal to the sum, which means to add, of the two non-adjacent interior angles. This is the adjacent angle to our exterior angle. These are non-adjacent. They're not side by side. So 5x minus 27 plus 7x minus 26 is equal to that exterior angle, which is 10x minus 23. So 5 plus 7 is 12x. Negative 27 and negative 26 is going to give us negative 53. And that's going to equal 10x minus 23. Let's move the 10x to avoid a negative with division, and then we'll have 2x minus 53 is equal to, that's going to give us 0, and 0 minus 23 is negative 23. To solve for x, we're going to add 53 to both sides, and we'll get 2x is equal to 30. Since we're solving for x, let's divide by 2, and we'll get x is equal to 15. So we know what x is, but the directions want us to find angle A. And angle A is 5x minus 27. So 5x minus 27. That'll be 5 times x minus 27. So 75 minus 27, which is going to give us 48 degrees. So now we're going to move on to isosceles and equilateral. Remember, isosceles has 2 congruent sides. Equilateral has 3 congruent sides. So looking at this, I see that I have my 2 congruent sides. Now, according to the isosceles triangle theorem, if you have 2 congruent sides, then the base angles, which are opposite of those sides, are congruent. So if P is 74, then R is also 74 degrees. And if you want to find Q, do 74 plus 74, 148, and then do 180 minus 148, which is 32 degrees. Number 10, okay, you've got 2 congruent sides here and here. So we know that the base angles, which are E and G, are congruent, okay? They're exactly the same. So I know 2x plus 106 is equal to 180. Why did I do 2x? Because I can let this be x and this, because they have to be the same, and x plus x is 2x. Subtract 106 from both sides, and I'll get 2x is equal to 74. So each x is equal to 37 each. So E is 37 degrees, and G is 37 degrees. Number 11, see how B and C are the same? So this is the converse of the isosceles triangle theorem. You've got your two base angles congruent, then that means the two sides are congruent. So if AB is 9 feet, AC is also 9 feet. Now to find angle A, just add 48 and 48. And then do 180 minus 96. We have 84 degrees and 9 feet. All right, now this is equilateral. If you have an equilateral triangle, that means your angles are equiangular. That means they're all going to be congruent. So if you take 180 degrees and divide it by 3 equal angles, that means each angle has to be 60 degrees each. And that's not ever going to be different with equilateral. All right, so number 13, we're looking for x. So we have our congruent sides, which means these two angles are going to be the same, okay? So one way you could do this is you could say 180 minus 34 and see what's left for these two. So we're going to share 146 degrees between our two base angles, which are going to be the same. So 8x minus 23 plus 8x minus 23 is equal to 146. So 16x, when I combine my x's, now combine your constants, negative 23 and negative 23 is negative 46. So we get 16x minus 46 is equal to 146. Okay, so with that being said, add 46 to both sides, and we'll get, I'm running out of room here, 16x is equal to 192, and now divide by 16. 16 will go into 19 one time with 3 left over. 16 will go into 32 2 times, and we get x is equal to 12. And we were just solving for x, that's all we were doing, so we're in good shape. Now another way we could have done that is after we subtracted the 146, we could have just divided it by 2 to get 73, and we knew that each of these were equal to 73, and we could have just done 8x minus 23 equals 73. We would have gotten the same answer, but just another way to solve it. But I want you to see both ways instead of just one. All right, so these three tell me that this is an equilateral triangle, which means my sides are equiangular. So my sides are 60 each. All of these equal 60. So the easiest way to do this would just be 9x minus 3 equals 60. Add 3 to both sides to get 9x is equal to 63. And divide both sides by 9 to get x equals 7. All right, number 15. In triangle CDE, it's an isosceles triangle. Tells me that D is congruent to E. So that means that this side is congruent to this side. It has to be opposite of your two congruent base angles. CD is 4x plus 9. DE is 7x minus 5. And CE is 16x minus 27. Okay, find x and the measures of each side. So we're going to have to use the two congruent sides in order to find x. And how did I know these were congruent? When it told me that D was congruent to E with my angles, I knew the sides opposite would be congruent. Okay, that's the converse of the isosceles triangle theorem. So I know that 4x plus 9 is equal to 16x minus 27. Let's subtract the smaller x, and that's going to give me 9 is equal to 12x minus 27. Add that 27 to both sides and divide by 12, and we get x is equal to 3. So we know what x is. Let's plug and chug and figure out what our three sides are. So to find out CD, we'll have 4 times x plus 9, which is 21. To find DE, we'll have 7 times x minus 5, or 21 minus 5, which is 16. And then to find CE, which should be the same thing as CD, we'll have 16 times 3 minus 27. Okay, so x was 3, CD was 21, DE was 16, and CE was 21. And see, you got your two congruent sides here. Okay, this is page 2.